Okay, Assalamualaikum dan salam sejahtera. Okay, in this session, we will look at the second method on how to test slope of a regression line, using ANOVA table or analysis of variance. Okay, so for this method, first we need to construct the table, where we have source of variation, okay, sum of squares, degrees of freedom, mean squares, and f-test. So we have used this table before in one-way ANOVA. So it is similar table. However, the calculation, for the sum squares, for regression, residual, and total, there is a specific formula. Okay. So for SS total, we take the value of sum of YY. For sum square of residual, of regression, we take beta 1, the coefficient for the predicted line times the sum SXY. And similarly, to find the residual, we minus SYY minus SSR, or beta 1 SXY. So similar concept. And then for total, n minus 1, and regression, it is always 1. So to find the residual degrees of freedom will be n minus 1 minus 1, so n minus 2. Okay. And for mean square, we divide the sum of square with the degrees of freedom, so you will get mean squares. And then similarly for mean square of regression, so SSR divided by 1, and then which is equal to SSR, and mean square residual will be SS residual divided by n minus 2. And finally, the test statistic for F test will be just the ratio between MSR divided by MS residual. Okay. Now to determine the critical value, it will be F alpha, okay, 1 n minus 2. Okay. So remember that for F distribution, for ANOVA, specifically, it is always right tail. Right tail test. For ANOVA. Okay, it's always right tail test. So that is why for alpha, you don't have to divide it by 2. Okay, so the degrees of freedom will be 1 and minus 2. Okay. So this is how we use ANOVA table to solve the slope, or to test the hypothesis for the slope of regression line. So if it is 0 and if it is not 0, that is beta 1 equal to 0. This is the slope. Or we call it regression coefficient. The null hypothesis is when the slope is 0, and the alternative will be when not equal to 0. Okay. So for F test, we take from the table, and critical value, like I mentioned before, and then we compare between F test and F alpha 1 n minus 2. So if it is greater than, so we know that this is F test. So it is always right distribution. F test is positive distribution, right skewed. 0 to infinity. So if this is F critical, alpha 1 n minus 2. So if we calculate from the sample, our F test falls in this region, in the shaded region. So we will reject H naught. Reject H naught. Okay, that means we compare, using this comparison. That means slope of regression line is not 0. So conclusion, at alpha 0.05, for example, significance level, there is a linear relationship between the dependent and independent variable. Okay, it is when we reject the null hypothesis, that is beta 1 not equal to 0. Okay, so you must have, every time you do hypothesis testing, make sure you have 5 steps. 1, 2, 3, 4, 5 steps. Okay, so this is the example to illustrate on how to use ANOVA table to solve or to test the hypothesis testing for the regression, for the slope of regression line. Okay, so similarly, like in the formula shown before, so this is SYY, and so on. So this one is SSR, which is beta 1 time SXY. Yeah, beta 1 times SXY. So this is beta 1 times SXY. Okay, so for the residual, it's just the balance of that SYY minus beta 1 times SXY. Okay, so in the question, there are given 20, yeah, 20. So 20 minus 1 is 8, 19. Okay, for degrees of freedom for regression, it's always 1. Yeah, so 19 minus 1 equal to 18. Okay, and then to find the mean square, we divide sum of squares, divide by degrees of freedom. Okay, similarly for residual, mean square of residual, 6402.65 divided by 18. Okay, and then finally to find the F test or the test statistic value, simply mean square regression divided by mean square residual. Okay, so we get this. Okay, and then we will compare this value with the critical value from the statistical table, 0.0118, which is this. So we can see that this value here is much larger than, yeah, the test statistic from the sample that we have is much larger than the value from the table. Yeah, that is the critical value. Therefore, we reject H naught, beta 1. Reject H naught, beta 1 equal to 0. That is the slope is not 0. Yeah, reject H naught. Okay. So it shows that beta 1 is actually not equal to 0. So in conclusion, at alpha 0.01, there is a linear relationship between the dependent and independent variables. Okay, so in the next section, we will go through exercise 5.3. Okay.